Hello, and good afternoon. Thank you for coming back right after the tea break. I'm going to talk to you about lessons from database failures. I've had a long and varied history with database failures. I've been working with MySQL for about 15 years, and a whole bunch of other random things. I'm going to really just focus on a few things: backups, and the fact that you actually need to verify those backups, replication, and how you handle failover, security, as well as encryption, because that's becoming a lot more important topic today. I'm not going to talk to you so much about MySQL cluster, which is internally known as NDB cluster. It's an engine. That generally doesn't fail. That's why it's used in the telco space very effectively. It tends to promise 5 nines uptimes, and if you use the cell phone, which presumably all of you have, and when you switch cells, the home location recorder information is actually usually stored in NDB cluster to keep your position known to the telco. It's also extremely hard to set up. It's extremely hard to upgrade. It may require something like 52 to 54 commands to upgrade. So it's extremely resilient, except when you need to actually do operations on it. So I'm not sure how many of you remember Magnolia. This site was around 10 years ago. They promoted open standards, micro formats. They had a paid component to it. As you can tell, it doesn't look so good because I took this from the Wayback Machine. It doesn't exist anymore. Magnolia had a complete failure. They lost the user database in 2009. It took them about 3 weeks to realize that the UDB was confirmed dead. I guess you may have heard of the service that came after Magnolia, Delicious. Delicious kind of won because Yahoo acquired them, though that may itself not be a win. Yahoo then sold them off again. It turns out that they were running Ruby on Rails with a bunch of Mac minis using Xserves. Apple doesn't make them anymore. And they had all these MySQL 5 databases. What they encountered was file system corruption. And file system corruption can happen when you have HFS+. HFS+ is great for a laptop, but it's not so great for a server. This is why, generally, when you run database servers, you use XFS or ext4. Never anything else. Probably in the future, we will see more people use ButterFS or ZFS. But more or less, you never run production database on HFS+. It's just a bad idea. They also then ended up having a corrupted database backup. And that was largely because they were doing rsync backups over the FireWire network. You can't rsync a live MySQL database. That's just not how it works. You actually have to use online backup tools, but never rsync because the data is constantly changing. We don't actually know if they used MyISAM or InnoDB, but being MySQL 5, we will presume they were running MyISAM as well. Today, you probably learn from Magnolia and figure out what not to do. I think that's the most important thing you can actually learn from database failures, or any failure for that matter, is you learn something you never will repeat again. And then today we share those things, and hopefully other people don't repeat them again. So today, I would run Magnolia probably on EC2. I am very unlikely to create it and go and buy some Apple hardware. I end up using EBS snapshots. I'd even use RDS with snapshots so that Amazon manages the database for me. RDS is great while I'm going to grow, right? I can have 40 instances with a default account as long as they have my credit card details. I would choose multi-AZ deployments so that if an availability zone goes away, I'm good to go. And AZs differ based on regions. Some regions have 5 AZs, some have maybe 2. But I'm guessing a lot of you are also operations people. We are, after all, at the Operations Tune conference, so I'm guessing some of you also do self-hosting. How many here do self-hosting? Okay, brilliant. So once you outgrow RDS and EC2, you probably want to actually install MySQL on an EC2 instance, or have your own hardware. Today, you do backups with Percona Extra Backup. This absolutely makes sense. You don't actually have to use MySQL dump. MySQL dump is good for logical backups, extra backup is great for you to do point-in-time backups and point-in-time recovery. And if you use extra backup, you'll probably also use extra DB, either in MariaDB server or Percona server, and you get what is known as bitmap change page tracking. So you don't actually have to do incremental backups of everything. You just look at the changed bitmaps inside InnoDB and have those backed up. It's much quicker for a backup and a restore. Another thing you can actually end up doing if you want to provision a new slave, which is likely when you want to grow, is you will end up doing start transaction with consistent snapshot and then execute a single transaction MySQL dump that will record everything in a logical backup form before you executed start transaction with consistent snapshot. The old way to do this would be to end up having to do flush tables with read lock and then do a backup. Now you don't want to do that today. You obviously also take backups, not of your live systems, but of replicas. So you don't back up from a master, but you ensure that at least one slave is up to date, and there are ways to ensure today that slaves are up to date. And another very cool thing I would recommend you to do is to turn on replication event checksums available in MySQL 5.6 and greater and MariaDB 5.3 and greater. This more or less can either run on the master or the slave, but it'll do an event checksum. Let's say you run it on the slave to see if it matches what's on the master, and if the checksums mismatch, replication will stop. This is extremely important because it's great to replicate data, except if your replicas are bad. Then you've replicated bad data. And that's a very common problem if you had happened to use statement-based replication in the old days. Today, mixed mode is the default, and binary log replication is more or less preferred. Does anybody use couchsurfing? OK, a bunch of you, excellent. So couchsurfing introduced the concept of, well, I guess today you'll get more of these things called incident reports. They are a lot more common. The concept is much newer. We didn't have them during the Magnolia days. Couchsurfing had a major avoidable hard drive crash, and their backups weren't executed in a correct manner. So they've lost a lot of their data files. Couchsurfing more or less survived because Airbnb did not exist back then, even though they do two different things. How would you fix couchsurfing today? Simple. You'd use time-delayed replication. MySQL 5.6 and greater has time-delayed replication so that if you want to set a replica to be 10 minutes behind the master, 2 hours behind the master, you can do that. It is implemented on a per-slave level, so it'll actually hold the SQL thread, and the replication delay can be whatever you set it to. This is actually extremely useful when you find that a developer or even an operations person has made a mistake on a production database and you need to roll back. You use a delayed replica. Unfortunately for couchsurfing, they couldn't use this exact feature back then when it occurred, largely because it was a feature suggestion in 2001. A bug was formally opened in 2006. It only got pushed into a tree in 2010, and it was a GA only in 2013. And now we're 2016, MariaDB still does not have said feature. So things can take a long time to appear in the MySQL world, and that's something to remember. I guess it's also very important to remember to always use modern software, and this goes for all kinds of software, not just database software. And there's no real excuse not to use modern software when you're using open source tools, because there's no like licensing cost to upgrade. So why replicate? There are a whole bunch of reasons why replication makes sense and why you should do it. Many people do it for scale-out purposes. Many people also do it for failover. Sometimes you want to do a full automatic master failover, and the tooling is there. You just have to work hard to make a full automatic master failover today. And sometimes you may want to do a failover that is not fully automated, where you actually ping operations. Another common interest is to have geographical redundancy across data centers. I love to use my American Express credit card, and when I landed in Seoul a couple of years back, I couldn't swipe it. In fact, I couldn't swipe it all week. And it turns out that was because Samsung was the sole provider of AMAX services in Korea, and they had a data center fire in Ilsan. So it affected all of American Express inside of Korea. Now, if you were outside of Korea and you happened to use a Samsung device, all your Samsung services went off, your Samsung TV wouldn't work, and it was a Sunday in most of the world where it wouldn't work. So you want to protect against data center fires, for example, or floods, and so forth. And I think the most common use case is online schema changes. And online DDL can also cause replication lag. There are multiple ways to do this. You could use PT online schema change. Things are improving to give you even online DML in future versions of MySQL. So it's very important to keep up to date and abreast with new things. And here in the UK, the GDS wrote an excellent long blog post about how they were using online schema changes for their MySQL. And we've seen multiple people do this even with Galera clusters, like, say, TaskRabbit. And we've seen Wikipedia talk about what they do with it, 37 signals as Basecamp, and so forth. And now there are multiple ways to do online schema changes. In fact, GitHub, about a month ago, released something called Ghost. And Ghost is a front end. It's not PT online schema change, it's not Oak online alter, but it's something that GitHub uses every day to make online schema changes. And it is much more robust and reliable than you would think, since it is actually powering GitHub's changes, which I'm guessing a lot of you use every day also. So when it comes to replication and why MySQL itself got largely popular is because default asynchronous replication works out of the box. You can actually make a commit and ensure a replica exists in maybe even less than 20 milliseconds or 30 milliseconds. Being asynchronous also means that you can send stuff to a master and there's no guarantee a slave will get it. This is not how we'd like to run services today. Today, I'd like to bring your attention to the semi-synchronous plugin. Semisync appeared in MySQL 5.5, and in MySQL 5.7 and MariaDB 10.1, you actually have what is known as the enhanced lossless semi-synchronous plugin. This more or less guarantees that at least one slave will get a transaction commit, which will then enable you to have tooling to do automatic master failovers in case a master goes down. In fact, very large services today run with semi-synchronous replication. So the likes of Google, the likes of Facebook, any large service you can think of, more or less probably has semisync turned on. And semisync is written as a plugin because you can't have it as a default, because you actually need to provide information about a slave. There is also synchronous replication, which some would refer to as the holy grail of replication, because it ensures that all nodes are either equal or no nodes get said transaction. The problem with fully synchronous replication, like Galera, for example, is that the more nodes you have, the longer it takes to have a transaction commit. So with the basic 3 nodes, you go from a 20 to 30 millisecond commit time to something like a 300 millisecond commit time. And this gets even larger when you start going across geographies, because we can't beat the laws of physics. You can't write to all nodes and expect you to say that it's going to be fast as well. And then there's DRBD, which is a great solution about 10 years ago, but honestly speaking, I don't think you need to use it today because there is good built-in replication inside of MySQL. It is reliable if you turn on all the modern features. So if you're using a modern MySQL, I suggest you don't need to use DRBD, which is RAID over Ethernet. There are also plenty of frameworks. Frameworks that help you replicate better, to handle failover better. There is MMM. This allows you to create multi-master topologies written in Perl, extremely hacky. In fact, I would say do not use this. When the website says do not use it, you should probably listen to them. There is cluster control, and I'm big on open source, but there is absolutely no other tool that matches cluster control, and it's not fully open source, unfortunately. It's good for you to get the tires kicking to see how quickly you can set up a 4-node cluster. Yes, I've timed it, it's under 5 minutes. You can set up Galera, replication, semi-sync, etc. It's got a nice GUI, point and click is cool. It also works with setting up HA proxy as a load balancer. It can roll out on-prem as well as say with EC2. Does workload simulations, but not free. Not so cool. Orchestrator. This one is something I'm really bullish on. It's Apache licensed, so easy for you to get, easy for you to contribute to. It reads topologies. It knows the state of each and every server by polling. You can modify topologies either via the GUI or a JSON API. You can also visualize long-running queries. You can kill those long-running queries. Orchestrator today is in use in places like Etsy. It's in use in places like GitHub. It started live at a place called Outbrain. Booking.com makes use of it as well. Orchestrator is a great tool for you to embrace and extend for managing topologies. MHA, also written in Perl, extremely versatile. I like Perl, by the way. I don't know about you. Extremely versatile, in use at multiple places. In fact, the author started work on this at DNA in Japan and eventually got hired at Facebook to write the automated failover tooling there. They don't use Perl there, they use Python, so they have got some new Python stuff going on for them. But MHA itself, as a whole, can do automated failovers via global transaction IDs, and MySQL has global transaction IDs now to ensure that each and every transaction is unique across your topology. There's Tungsten Replicator. Nice piece of software, acquired by VMware sometime last year, sort of not really developed since May of this year, so probably don't use it. MySQL is also starting to give you tools, because one of the cool things about many NoSQL solutions today is that they have tooling and things work out of the box. Here are tools that can either work with the Workbench front end or they're Python tools that can work independently that manage failover as well as failback. So if the machine comes back up again, it'll reattach as a slave, and you can then manually promote it as a master. So these tools exist as well. We don't know of many users of these 5-6 utilities yet, in comparison to, say, MHA, where we've seen the SK Telecoms group use it, Jet Air here in Europe, DARPA in defense, and so forth. So MHA obviously has more users because it's been around for a lot longer. There's also the Percona Replication Manager, PRM, which more or less will tie in with Pacemaker and ChorusSync. And it's very important to remember that when you use something like PRM or MHA, you always remember to enable StoneInt, right? You've got to shoot the other node in the head, because sometimes the master comes back and the transaction gets committed into 2 different places and life becomes miserable for you. There's also Replication Manager. This one's very much like MHA, written in Go, though, and it doesn't understand MySQL GTIDs, it understands MariaDB GTIDs. So now you have a choice. We've reached a fork in the road where you have MySQL GTIDs, which MySQL and Percona have, and MariaDB GTIDs, which only MariaDB has. They're both incompatible. Speaking of GitHub, they also had an incident report some time back. They were replacing DRBD. They were using PRM and a pacemaker resource agent. They wanted to have efficient failovers. DRBD has this cold start problem, right? DRBD has several inefficiencies. One is that you have to keep a machine, a passive master, just sitting there eating up electricity. CFOs hate that. The other problem with DRBD is failover time is anywhere between 1 to 10 minutes, depending on the size of the data. No one likes a cold buffer pool as well. If you have a half a terabyte database, a cold buffer pool can mean you're out for hours on end. So in Percona Server and MariaDB Server, there's this idea of replication prefetching and what is known as InnoDB fake changes. So you actually replay statements, and then you roll them back when it's time to, instead of executing commits, you roll them back so you actually warm up the buffer pool. Today you can replace this with parallel replication or intra-schema parallel replication. So GitHub's problem was they had poor performance and high load, leading to failing health checks that triggered failovers. So what they were actually encountering were failovers triggering other failovers. Then they had a pacemaker seg fault. This one's hard to fix. This is again why I'd recommend you doing things with MySQL as opposed to doing things inside of Linux itself. They also started realizing they were getting data drift, so inconsistencies between MySQL and Redis, the other data store. And the root cause in the incident report was that automated failover was the root cause of all their problems, because failovers brought on more failovers. And this was a couple of years ago when GitHub was hit, and I'm guessing you probably encountered it because for approximately over a day, you were extremely productive. So, is fully automated failover a good idea? Sometimes you have false alarms. Repeated failovers. What PRM was missing at that point in time was never allow a failover to happen if it happened in a certain period of time. MHA, by default, does not allow a failover to occur if it occurred in the last 8 hours. MHA will start, but it will not create a failover. Data loss is a problem, and you may actually realize you've lost some data. This you can mitigate today by ensuring you have group commit in the binary log. If you use any modern MySQL or MariaDB, you can turn on innerb flush log and transaction commit and sync bin log equals 1 with no performance loss, because it doesn't actually call fsync each and every time, it groups those commits. And data loss. If you use semi-synchronous replication, you should have 0 data loss problems. The other problem, obviously, is split brain. You obviously need to practice StoneInt. Power off can take some time, and power off also depends on the kind of infrastructure you have. If you're using EC2, you have APIs. If you're using hardware, some of them use me-tools, some of them use Telnet, etc. All this said, today, you should have 0 problems doing fully automated failover with a 30-second SLA with tools that are available and semi-synchronous replication, because that is what some very large social networking sites can promise you today, internally. Proxies. You need to think about sharding as you grow. Sharding because you end up outgrowing one single instance. There are many sharding solutions, and one of them that I personally like a lot is Vitess. Vitess is what powers YouTube. So it's powering a very large site that many people visit on a daily basis, and it can handle things like query rewriting as well. So if your developer sends a query over and forgets the limit clause, you can rewrite said query to ensure there's a limit clause. In fact, it also allows you to ensure that you have very small BSON lightweight connections. Each connection in Vitess is 32 kilobytes in size. Each connection in MySQL ranges from 256 kilobytes right up to 3 megabytes. There is also MaxScale. That is a pluggable router. It's a great piece of software. You can use it for logging. You can use it to write to other database backends. You can also use it as a firewall. You can also use it as a binary log relay in case you realize you have many multi-tiered architectures. The most popular use today is load balancing Galera clusters. Galera clusters are also becoming extremely popular today, 3, 6 nodes, maybe even 9 nodes. And having MaxScale say some nodes are going to get writes, whereas all the nodes are going to get reads is also a way to actually increase the performance of Galera, which is fully sync replication. The only problem with MaxScale is, my recommendation to you is to use MaxScale 1.4, which is fully GPL, because MaxScale 2.0 has got some convoluted license called the business source license, where you can see the source, but you actually have to pay to use the proxy if you have a production workload. Good news for you is MySQL is here to save the day. They've also got Router and Fabric. Router is their MaxScale equivalent from Oracle. It's fully open source, it's GPL, and Fabric allows you to manage clusters of servers. And the additional good news is Proxy SQL. Proxy SQL is more or less going to be a MaxScale replacement, at least for Galera cluster users today. We've seen many users say that they really like the fact that it handles persistent connections. It can also do query caching, which ensures that if you run benchmarks against Proxy SQL versus a MaxScale, because it caches the queries, it seems to be extremely fast. We've seen many users, and one of the famous ones that have written a blog post, at least, or a report is Nilas. I'm very bullish on Proxy SQL because it is completely open source, and what more do we like than fully open source world? So in the last couple of minutes, I'm going to spend a little time on security. So the Philippines had voter data show up in a 338 gigabyte MySQL dump. Inside that dump, you would find email addresses, passport numbers, and even fingerprints of Filipinos, especially overseas Filipino workers who are going to vote. This data is available for you to download, and it's not good. Actually, medicine, much easier data set for you to play with. Only 7 gigs to download. Inside, you get 36 million email addresses, over 9.6 million credit card transactions. You also get names, street addresses, email addresses, phone numbers, and all those credit card transaction details. You also get a schema, so if you ever wanted to build Ashley Madison or an equivalent, you could study it. It's a good data set to play with. Patreon. This one personally affected me. I like to, support independent artists or writers and so forth. Their entire dump, 99 tables, so you can also see the schema. One of the other probably more famous ones would be Panama Papers. Thankfully, they didn't run MySQL because Mossack Fonseca paid to ensure that their Drupal and WordPress would run with Oracle as a backend. And they still got hacked. So today, you want to definitely think about preventing SQL injections. Maxscale's database firewall filter actually just works. It works in the 1.4 GPL version, so go get it. Use the DB firewall filter. The thing about SQL is you need a parser, and then you can feed it regex. But you can't actually parse SQL with just simple regular expressions. You actually need a parser, and Maxscale 1.4 has a MySQL parser built in. So it's well worth for you to actually go check that one out. So you prevent, and SQL injection is the easiest way for people to get into your database. I mean, that's what happened to all these other sites. Enterprise firewall, nice tool, but it costs money, so we won't talk about it. Encryption. All of this could have been prevented if they encrypted their MySQL databases. Today, you want to think about encryption either in ways of you encrypting columns, so you can either encrypt individual columns and access it via an ORM. This is OK. There's also, but this actually will prevent direct access via SQL. You may also want to do column encryption via middleware. There are things like MyDiamo, CryptDB, and so forth that exist. There's also the option of de-encrypting your full system. This one has CPU overhead because every time you retrieve pages to the buffer pool, it has to decrypt, and your logs are also obviously available. You want to think about encryption from a way that drive-by exploration is impossible. So the attacker not only steals the data, but also steals the keys to the data. So MariaDB Server 10.1 includes table or tablespace encryption, not invented at MariaDB, but invented at Google, because Google actually runs in fully encrypted mode after they found out that the NSA was spying on users, thanks to Edward Snowden. So the design goal was to encrypt everything. InnoDB data, logs, binary logs, temporary tables, temporary files, everything is fully encrypted. Key management, you can put it on the file system, but they take away the key when they break in. Not a good idea. You also don't get key rotation. So Amazon has a KMS. It's cheap. You use the plugin. You can more or less get like 1,000 key requests for like $1. Cheap. Well worth trying. Caveats obviously include that MySQL binlog itself, if you have a replication problem, you can't actually read encrypted binary logs. And if you're using this with Galera, the Gcache isn't encrypted. This will all get fixed in something like 10.2. MySQL 5.7, not to be left out, also has a tool available for you to encrypt InnoDB table spaces. You must use InnoDB file per table, which is the default nowadays anyway. And the logs still remain unencrypted. But we saw this come as a post-GA feature, so we expect that the same thing would happen as well down the line. And it's interesting to watch this space because Percona is also looking very carefully at encryption at rest, and maybe Percona Server will not only offer you the 5.7 option, but the MariaDB option as well down the line. So, in conclusion, I suggest you learn from others. Use semi-synchronous replication with a failover solution to ensure you never fail too often. You want to make good backups, but making good backups alone isn't enough. You want to test them, and you also want to save them. So make logical backups, make physical backups, and so forth. You'll definitely want to shard your data. use proven frameworks. Maybe you need to involve a proxy. You also want to think about complete backups from time to time, and that's what multi-source replication exists. MariaDB has it for 64 channels, MySQL for 255 channels. Use MySQL dump and extra backup together. I'm sure if you've done this dumping before, you'll realize that loading up dumps take a lot of time. So MyDumper allows parallel backup as well as restore, and MySQL Pump, a new utility that will also do the same thing. And security is really key. You want to make sure you prevent SQL injections, and you want to encrypt your data at rest. There's probably no reason now for you not to do either. Encrypting your data at rest is not even a 1% extra overhead. When you whack it with benchmarks, fully synthetic, you can at most get a 5 to 7% overhead. But you shouldn't be running at that CPU usage anyway. So more or less, I'd like to say thank you. The slides will be up available online. You can email me, tweet me, or ask me questions if we have time.